Today we are going to do scale drawings. And we're basically going to use proportions for these. So let's say I have a triangle and another triangle, and I say that they're similar. Now that means they're in proportion to each other. Let's say this side is 5. Let's say this side is 28. Let's say this side is 12. And this side is x. And I want you to find x. I can use a proportion. Now I need to set up so that I have, that I'm consistent. There's lots of ways you can set it up, but I just need to be consistent. Do you see this side that I marked in red? It corresponds to this other side that I marked in red, which means they're in the same spot. So they're in proportion. So I would say 5 is to 28, as 12 is to x. Notice how I went from small triangle to big triangle, small triangle to big triangle, lining up their sides. Now this is a proportion like we did yesterday, so we cross multiply. And I get 5x equals, what's 28 times 12?
336.
Say slower.
336.
336. That's what I heard. Then we divide by 5 and get
67.2.
Okay, so that is x. Let's say this side right here, I'm just going to make up a number, maybe
3. Wait, no.
8. Let's do y. Now I don't want to use this thing that I just calculated. Maybe I made a mistake, or maybe I needed to round. So I'm going to do 5 is to 28 as 8 is to y. I cross multiply, I get 5y equals, what's 28 times 8?
224.
And then I divide by 5 and get
44.8.
reasonable enough. Any questions? No? Okay. Let's do another scale drawing. Notice I have to tell you that they're similar. That means they're in proportion. So how do I set this one up? I need to identify the corresponding parts. Luckily, they're already like oriented kind of the same way, so it's pretty easy to figure out that 7 corresponds to the 12. Those are the corresponding parts. So I'm going to do small to big. You could do big to small if you wanted. It doesn't matter. You just need to be consistent. So 7 is to 12 as 6 is to x. And just to emphasize that point, I could do 12 is to 7. See, I'm going the other way now. And that would mean x is to 6. Do you see how I reversed it? In the end, notice I still end up multiplying the same things. What's 12 times 6? In both cases, when I cross multiply, I end up multiplying the same numbers. So as long as you're consistent, it's fine. And what's 72 divided 7 to the nearest 10?
Well, 10.29.
Okay, so 10.3 to the nearest 10.
Oh, you said it about that.
Okay, so we'll get the same thing no matter what. Give you a moment to copy that down.
And couldn't you do it like 6 over 7 and x over 12?
So short side to long side, as short side is to long side, and notice I still am multiplying the same numbers. Yes.
So you could. Will it be like that for every one of them?
Yeah, as long as you're consistent. So if you compare short side to long side to long side, your comparison just has to be the same. I couldn't switch it around. I can't just randomly do it.
So which one do you prefer to do?
It doesn't matter. Just be consistent.
Okay.
Okay? Whatever way you understand it is fine. Okay, so in the diagram, just look at this, please. Notice I give you the similarity statement. When you do a similarity statement, the corresponding parts have to line up. So A corresponds with D. So those angles would have to be equal. And B corresponds with E. So those would have to be equal. See how I'm marking them? And C corresponds with F, because they are in the same spot. Now I oriented those angles, those triangles differently. So they're flipped, one of them's flipped around, you see what I mean? So, but these are similar. But do you see what I mean? I have to write my similarity statement so that the corresponding parts line up. So theoretically, you could do this without seeing a picture. So this means A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. Okay, so the angles, and this is a very important fact, very, very important, star this. In similar shapes, the angles are congruent and the sides are in proportion. So what that means is the sides are not necessarily equal, but the angles are. The angles have to be equal, otherwise you don't have the same shape. What side? Now let's think about the sides. Look up so you're catching this. I will give you time to get them. What side corresponds with side AB? So I'd say, now your book does a fraction thing. I'm just going to say AB is similar to what side? It would be DE. Okay, because I went from A to B, so I have to go from D to E. Alright, what side is similar to BC? So BC is similar to EF. So the order is going to matter there. And finally, segment CA is similar to what other segment?
Yeah.
Do it in the right order. FD. Okay? The corresponding parts have to line up. So your book does do a fraction thing where they'll say the ratio of AB to CB has to be the same. All I want you to do is name which sides correspond, which sides line up in the same spot. All right, let's put some numbers to this problem as you copy it down. Let's say this is 8. Nah, let's not say that's 8. That's too small. Let's say this is 15. And let's say this one here is X. Let's say this one is 12. Say this one here is Y. Let's do this one is, I don't know, 10. Let's do this one here is, I don't know, 6. I don't know if this is even possible.
Which is like 4.
Well, if something weird comes out, we'll know. Okay, so suppose I wanted to find x. How would I do it? Name one way to find x.
Use a proportion.
Okay, set it up for me.
15 over 12 equals x over 6.
Yep, 15 over 12 equals x over 6. I could reduce that if I wanted. You don't have to. I will just to make the math a little bit easier. So we cross multiply and we get 30 equals 4x. Now what? And what's 30 divided 4?
Seven.
7.5. Okay. So this is 7.5. All right. Someone write a proportion to find y.
10 over y.
Equals what? So you did 10 is to y as,
16.
yep. So you flipped it around a little bit there. That's fine though. You were consistent. As long as you're consistent, it's all right. So I won't bother reducing this time. 15y equals 120. So I divide by 15. What's 120 divided 15? You okay over there, Train?
8.
What'd you say?
8.
8.
8. Okay, so y is 8. Any questions on scale drawing so far? Good, you guys are so smart. All right, here we go. Here is an example word problem. And because Ryan's whining about it, Ryan
I hate word problems.
casts a shadow that is 3 meters long. A tree nearby casts a shadow that is 100. Man, that's too much. We'll say 20 meters long. If Ryan is 1.5 meters tall, then how tall is the tree? So I'll draw a little picture here. This is Charlie Brown's Christmas tree. So we're wondering how tall the tree is. So hopefully you see the tree is probably 10. Okay, because double Ryan's height, you get 3. So half this, you get the tree, right? Kind of like common sense. But what we're getting at is theoretically, if you're standing outside at the same time, the relative length of your shadows will be in proportion to all the shapes that are casting a shadow simultaneously. So we could solve this. We could say Ryan casts a shadow, 1.5 is to 3, Ryan to his shadow, as the tree is to its shadow. That's one way to set it up. I could also set it up and say, well, let's compare their shadows. The 3-foot shadow compares to the 20-foot shadow as Ryan's height compares to the tree's height. In either case, as long as I'm consistent, do you understand how I set that up those two different ways? There's a couple other ways we could do it, but we'll just choose to solve one because in the end we multiply the same things. We get 3x equals, because we cross multiplied, and what's 20 times 1.5?
30.
And then we divide by 3 and get 10. So the tree is 10 feet tall, which confirms our common sense thinking.
What's up?
Austin, you getting all this? And then we only have one more thing really to talk about here. Well, two more things. Do we need another example? Do we not understand it? Okay. This is very important. Shapes are similar if their angles are congruent and their sides are proportional. Now we already wrote that, but I wanted to write it again because I spelled proportional wrong. Oh well. We're going on. So here's the question. I have two triangles, let's say, just because I'm liking triangles. And I want to know, are these similar? Well, let's just give us all the angles. So all the angles are congruent. Boom, boom, boom. So we'll assume the angles. But are the sides in proportion? Well, here's how I do that. I'm like, okay, this side corresponds to this side, right? So 8 is to 12. And then this side to the 15, right? Because that's the next biggest side. So 10 is to 15. And then this side to this side. So 12 is to 18. Now those look all different, but if they're proportional, then all of these reduce to the same number. So if I reduce 8 over 12, I get 2 over 3. And if I reduce this, I can divide both of those by 5, and I get 2 over 3. And if I reduce this, I divide those by 6, and I get 2 over 3. Notice each of those ratios reduce to 2 over 3. Therefore, I conclude these are similar. Does that make sense how I tested that? Or not really? Yes? No?
Yes.
If I got one of these were different when I reduced it, then they would not be similar. Alright, the last thing. Scaled maps. Obviously, when you get a map, it is not drawn to scale, meaning you don't have a mile-long map to represent a mile of... That's crazy. Imagine that scroll. You know, pick up that map, see where you are. You'd have to walk a mile just to see. That's crazy. So we scale it, right? Crazy, crazy. All right, let's say in my skill drawing I have 1 mile equals 2 miles equals 3 inches on my map. This is called my scale. And maybe I have here, this is Trey's house.
Hey.
And maybe over here we have Peppermint Patty's house has a nice, it has a nice little garage thing going on or something. So this is Peppermint Patty, and here, let's get Meredith in here. Meredith has one of those big, tall A-frame houses, we'll say. This is going to be Meredith. That's where she lives. And then I'm just going to connect these. Maybe they aren't directly connected. Here's the road. And let's say I measure this, and let's say this is 4 inches. Let's say this is 6 inches. And let's say this is 5 inches.
Wow.
Okay, because this is on my map. And I want to know, well, how far does Trey drive to meet up at Peppermint Patty's house? That must mean that Marcy's over there, hanging out, because it's Peppermint Patty's house after all. All right, so we want to convert this 4 inches to what? To miles. All right? So we see that according to our scale, 2 miles equals how much on our map? 3 inches. And scale, I don't know how far Peppermint Patty lives away from Trey, but on our map we see that she's 4 inches away. He's like, I just have to take a step. All right, no, I cross multiply and I get 8 equals 3x. Divide by 3 and x equals. What's 8 divided by 3?
8 over 3.
2.6.
So she lives 2.6 miles away. That's not bad. You could ride your bike there. You don't even need a car. You can walk.
I can't ride a bike that far.
Your mom's not taking you over there. You're crazy. All right, crazy Tracy. All right. So Trey's not allowed to go to Peppermint Patty's house because Marcy's over there, and that's not allowed. All right. So Trey decides, I'll be tricksy. I'll go to Meredith's house. She'll never know. She'll never figure it out.
That's 4 miles.
Okay, so this is six inches away. He's going to have to work for it now.
That's 4 miles.
So we're going to use our scale. So 2 miles is to 3 inches, right? So I'd be consistent. So we want to know how many miles away. So actual miles to 6 inches. Do we see how that is? And I made this pretty easy on us, didn't I? So cross multiply, 12 equals 3 inches. Divide by, or 3x, divide by 3, and x is 4 miles.
Oh, really?
Yeah, that's how it is.
What if we got 4.02?
Something happened to you. Because 12 divided by 3 should come out exactly 4.
This is why you don't show work.
Okay, do you see how we use the proportion? Okay. All right. Austin's room is 6 foot by 10 foot. It's kind of a narrow rectangle here. All right, and he wants to rearrange his room. He's going to draw a diagram, get some graph paper out, and he wants to use the scale. 1 inch is going to equal 2 feet. So how big is the scale drawn? And yeah, I made this pretty simple, so Trey's like, just divide by 2 when you put bonobo, and you get 3 by 5. Yes, but let's see, perhaps and I give you something weird. So we're going to do 1 inch is to 2 feet, so this is scale to actual, right? Do you see what I'm doing? Scale to actual. Now his actual room is 6 feet, right? And I want to know how many inches that is. Do we see how I set that up? Scale to actual. So scale, I want to know what the scale should be, so I cross multiply, I get 6 equals 2. Divide by 2 and get 3. And the other side, scale to actual. So scale to actual, 10. Cross multiply, I get 2x equals 10. So x equals 5. So his scale drawing is going to be 3 inches by 5 inches. Any questions how I did that? Is anyone lost on this stuff? All right, we're done with notes. Get a whiteboard and marker.